You are walking through ankle-deep water. The sand is warm, the water is clear, and everything around you looks completely harmless. And somewhere beneath your next step, there is a fish that has been waiting, perfectly still, covered in algae and reef debris, for something exactly like you to come along. This video is about the stonefish, and the reason it matters is not that it is venomous. Plenty of animals are venomous. What makes the stonefish genuinely different is where it lives, how it hides, and the fact that it does not need to do a single thing to hurt you. You do all the work yourself. Most people who have heard of stonefish picture something lurking in deep water, something you would only encounter if you were diving or snorkeling far from shore. That is wrong, and that gap between what people assume and what is actually true is exactly what makes this animal so dangerous. So, we are going to go through the whole thing, how it hides, how the venom system actually works, what happens to your body, and a few things about this fish that even people who study venom for a living find genuinely surprising. By the end of this, you will never look at a shallow tide pool the same way. Let's start with where this fish actually lives, because that is the part most people get wrong first. The stonefish is not a deep reef creature. It is not hiding in the dark where you would never go anyway. It lives on sandy reef flats, rubble zones, shallow lagoons, and in small pools that form during low tide. The exact places where tourists wade in without shoes because the water barely reaches their ankles, and nothing about it looks threatening. These are the spots where people mentally switch off their caution, where kids splash around and adults stand still taking photos, and the stonefish is sitting right there in the middle of all of it, doing absolutely nothing, which is precisely the problem. Here is what the camouflage actually looks like in practice. The reef stonefish, Camouflage varicose, has a body covered in warty, irregular skin that breaks up its outline completely. Its color shifts to match whatever substrate it settles on: brown, gray, orange, mottled combinations of all three. But the camouflage goes further than color, because the fish is so still, and because it often sits in the same spot for extended periods, algae and sediment actually begin to accumulate on its body. The reef starts growing on it. So you are not looking for something that resembles a rock. You are looking for something that has become indistinguishable from the actual reef floor, with living organisms growing across its back, sitting in the exact place your foot is about to land. And this is the part that the 2025 field study made genuinely alarming. Researchers looked at stonefish behavior across 4 public beaches in Eilat, measuring how the fish responded when approached. What they found was that the stonefish had extremely short escape distances, meaning it waits until something is almost on top of it before even considering moving. But more striking than that, 62% of the fish observed showed no flight response at all. They did not move. They did not shift. Something came close enough to step on them, and they just stayed. The danger is not that this fish comes toward you. The danger is that it refuses to leave. It is so committed to stillness as a survival strategy that it will sit there while you walk directly toward it, and it will be right where you left it after you have gone. So now you are standing in shallow water, you have no idea the fish is there, and you put your weight down. This is where the biology gets genuinely strange, and it is the detail that separates the stonefish from almost every other venomous animal you can think of. The stonefish does not bite, it does not chase, it does not strike, it does not do anything. What it has is 13 dorsal spines running along its back, each one enclosed in a sheath of skin with a venom gland sitting at the base. When those spines are at rest, the system is inactive, but when pressure pushes down on the spine, when your foot compresses it, the sheath is forced down, the venom gland is mechanically squeezed, and venom is pushed up through grooves in the spine directly into the wound. The fish does not attack you, you activate it. That is not a metaphor. That is literally the mechanical process. Your own body weight is the trigger. The harder you press down, and if you are walking normally, you are pressing down with your full weight, the more efficiently the venom is delivered. The spines can penetrate through the soles of most water shoes. They have gone through thin rubber. They have gone through the rubber of flip-flops when the angle is right. And because the fish is sitting flat on the bottom, and because you cannot see it, you often do not know you have stepped on it until the venom is already moving. Now let's talk about what that venom actually does, because this is not a simple story. For a long time, stonefish venom was described mostly in terms of pain, and the pain is real. It is widely described as some of the most severe acute pain a human can experience, the kind that causes people to beg for amputation within minutes of a sting. But recent research has started to reveal that the venom is doing far more than just causing pain signals. A genomic study of the reef stonefish identified 294 putative toxin genes in its genome. Not one toxin, not a handful. 294 candidate toxin genes, with metalloproteinases, C-type lectins and stoneostoxins among the most abundant. The stoneostoxin genes were found clustered together in a specific region of chromosome 2, which suggests this venom system has been under serious evolutionary pressure. The genome has been actively organizing and refining this arsenal over a very long time. This fish does not carry a toxin, it carries a library of toxins. And that library does different things to different systems in your body. Stoneostoxin itself is the main component responsible for cardiovascular effects. It can cause a drop in blood pressure, disruption to heart rhythm, and in severe cases, cardiovascular collapse. Separately, researchers have found neurotransmitters in the venom including GABA, choline, and O-acetylcholine. The presence of GABA in a fish venom was described as a first-of-its-kind finding. GABA is an inhibitory neurotransmitter. It is involved in calming nerve activity. Finding it in venom suggests the stonefish venom is not just damaging tissue, it is interacting with the nervous system in ways that are still being studied. So when someone describes a stonefish sting as the worst pain imaginable, they are not being dramatic. Their cardiovascular system is being affected, their nervous system is being disrupted, their tissue at the sting site is being broken down. Multiple systems are under attack simultaneously from a single accidental contact with a fish that was just sitting there. But here is the detail that a lot of people do not know, and it changes the picture in a way that matters if you are ever actually stung. About 10% of stonefish stings that present to hospital involve retained spine fragments. The spine breaks off inside the wound. The fish leaves part of the weapon behind, and because stonefish spines are radio-opaque, doctors can use X-rays to find the fragments, but only if they think to look, and only if the patient mentions the possibility. A fragment left in the foot can cause ongoing infection, inflammation, and complications that last long after the initial venom has been treated. The sting is not necessarily over when the pain starts to fade. Treatment for stonefish envenomation involves immersing the affected area in hot water, as hot as the patient can tolerate without burning, which helps break down the heat-label components of the venom and provides significant pain relief. But antivenom exists, and the way it is dosed is one of the more striking details of this whole story. Australian medical guidelines tie antivenom dosing directly to the number of visible puncture marks on the skin. 1 vial for 1 or 2 punctures, 2 vials for 3 or 4, 3 vials for 5 or more. Every spine mark matters. Each one is a separate delivery point, a separate channel through which venom entered the body. A person who steps squarely on the fish's back might have 5, 6, 7 punctures across the sole of their foot. That is a 3-vial situation, and it is a medical emergency. That is important to understand on its own. But if you want to understand the stonefish fully, you also need to know something about what it is actually doing when it is not waiting for someone to step on it. Because the venom system is not just a defense mechanism. It is also connected to how the fish feeds. The stonefish is an ambush predator. It sits motionless for hours, completely still, and then, when a small fish or crustacean passes close enough, it strikes, not slowly. The Australian Museum notes that the feeding strike of the reef stonefish is so fast that high-speed camera equipment is needed to record it properly. For hours, it is frozen like stone. Then for a fraction of a second, it is one of the fastest strikes in the ocean. The contrast is almost hard to believe. The same animal that will sit still while a human walks toward it will move faster than your eye can track when a small fish gets within range. And here is something that connects the venom system to the feeding strategy in an unexpected way. A study from James Cook University looked at how starvation affects venom production in the estuarine stonefish. After 4 weeks of food deprivation, key venom components showed some ability to regenerate, but the overall quantity of venom did not fully return to initial levels. That means producing venom is biologically expensive. The fish's body has to invest real resources to maintain that venom supply. It is not an unlimited weapon that refills automatically. The venom system has a cost, and when the fish is not eating, that cost shows up in reduced venom capacity. Which tells you something interesting about the evolutionary trade-off this animal has made. It gave up speed, agility, and the ability to escape as its primary defense. It gave up bright warning colors. It gave up everything that makes most dangerous animals recognizable as dangerous. In exchange, it became so good at stillness, so committed to invisibility, that it turned its own immobility into a weapon. The venom is the backup when the camouflage fails, and the camouflage almost never fails. If you have made it this far and you want to see more videos like this, animals that are genuinely surprising, biology that is stranger than anything you would expect, subscribing actually helps more than most people realize. It tells the algorithm this kind of content is worth showing to more people, and it means you will see the next one without having to go looking for it. And if you have ever had a close encounter with something in the ocean, or if you have a friend who insists on walking barefoot on reef flats, drop that in the comments. Those stories are always worth reading. Now, let's bring this together, because there is a bigger picture here that is worth sitting with for a moment. The stonefish is not a monster, it is not aggressive, it is not hunting you, it is doing exactly what it evolved to do, sitting still, staying hidden, waiting for food, and defending itself passively when something accidentally makes contact. The problem is that its environment and ours have started to overlap in a very specific way. The shallow, warm, clear water areas that tourists flock to are exactly the habitat the stonefish prefers. The sandy lagoons, the reef flats, the ankle-deep pools at low tide, these are not the fish's territory that we are invading. They are shared spaces, and most of the people walking through them have no idea what is down there. The 62% of fish that showed no flight response in that islet study were not being aggressive. They were being what they are, an animal that has survived for millions of years by refusing to move, by becoming part of the landscape so completely that even the reef grows on it. That strategy works extraordinarily well, right up until the moment a tourist in water shoes decides to stand still and take a photo, and puts their weight down on something they assumed was a rock. The solution is not to avoid the ocean. It is to shuffle your feet when you walk in shallow reef areas, which disturbs the sediment and gives anything resting there a chance to move before you step on it. It is to wear proper reef shoes with thick soles, not thin sandals. It is to pay attention in the water the same way you would pay attention crossing a street, not with fear, but with awareness. And it is to know that if you do get stung, hot water immersion is the immediate response. You get to a hospital, and you tell them exactly what happened so they can look for retained spines and dose antivenom correctly. The stonefish is one of those animals that rewards knowing about it. Not because knowing will make you afraid, but because the biology is genuinely fascinating and the practical knowledge is actually useful. An animal that has 294 toxin genes organized in its genome. That carries neurotransmitters in its venom that science has never found in a fish before. That can sit so still for so long that the reef grows on its back. That strikes faster than a camera can record, but only for prey. For everything else it just waits. And when you step on it, it does not attack. It just sits there, the same way it always has. You are the one who made it dangerous. You activated it. That is the stonefish. And now, the next time you're standing in shallow water somewhere warm and clear and beautiful, and you look down at what you assumed was just a rock, you are going to look a little more carefully, and you should. If this one surprised you, the video on the cone snail is worth watching next. Same idea. An animal hiding in plain sight, in places people feel completely safe, with a venom system that works in ways most people would never guess. It is right there on the screen. Go watch it.